Hello, and welcome to the LTS101 webcast and technical update. My name is Doug Colt, and I'm the product line director for the LTS101 engine. I'm here today with Jim Ebken, our customer service engineer, Lori Cartledge, our manager of customer product support, and Derek Herfer, our customer support program manager. So our agenda today, first we will discuss the strategic focus that I've been presenting at our operator conferences for the past few years. And then second, we'll have Jim Ebken present the technical details of our engine projects. So as always, we've got a great deal to discuss today, so let's get started. Please understand that the information that we present today is proprietary to Honeywell and is not to be shared without permission from Honeywell. For those of you who attended the past webcasts and operator conferences that we've had, you'll recognize the slide. It's the strategic focus that I outlined for the LTS101 engine back in 2012. Our theme at Honeywell is to understand our customers' needs. So whether you're an operator or an MRO shop, you're part of a business that's trying to make money using our engine. And that means our engine has to provide the value you need to make a profit. So I've outlined what I think the value Honeywell needs to provide is, here with the 4 bullets. Number 1, we need to continue to fund the top operational and field issues that our customers are experiencing. Our strategy here is to fund, solve, and fix all of the engine issues we have. Over the last 2 years, we've managed to knock out several of these, and this year, we're striving to do the same thing. Number 2, we need to restore the temperature margin on our single engine fleet. This has been going on for a while, and we're not giving up. It's something we have to do and we have to complete. And for those of you that don't know, as a result of Service Bulletin 248, we switched to what we call the dry rear bearing support housing. And in doing so, we robbed the engine of anywhere from 25 to 30 degrees of temperature margin. Our goal continues. We will restore this margin and get the torque limited operation back. That's what's expected from the engine, and that's how we sold the engine. So we've been working diligently to fix this for about 2 years now. We've made some significant gains. Jim's going to go into those with his technical discussion, but we're still ongoing here. Number 3, we need to reduce our operating cost. Here we're managing our spare parts pricing. We're adding component repairs. We're eliminating redundant inspections, all with the goal of lowering the hourly cost of the engine. 4, lastly, we complete our new product launches. So the Eagle 407 HP has made its entry into service this year. It's currently working up in Canada in a bucket lift operation, fighting fires. The performance is everything we said it would be, and the operator is just absolutely thrilled with the results. The next slide, it shows the status of our 2015 goals, and these are the goals that I outlined at HOC conference back in Florida in March. As you'll see in Jim's presentation, there's more that we're working on here than what's listed, but these are the big items that I'm really pushing for. Now Jim's going to go into detail and talk about each one of these items, so I won't spend a great deal of time here. I just want to cover a few of the higher points. So as far as the turnaround time on the ribbish repairs, we've improved this greatly with Greer. Now, we worked with Greer on a number of things. First of all, was their process, also their portal, the information they were providing in the portal, and we also had them put in place a customer service person that answers the phone and will talk to customers and explain what's happening to their parts. With all that, we've improved the ribbish repair turn time greatly. As part of that, many of you know that we've had some tubes breaking, the air buffer tube and the scavenge tube. And we've now got a repair in place to fix that. We got a weld repair. It's actually an improvement to the part. And so we're getting those to flow much better. So those are all complete. Those are in place and they're moving forward. The next item, the customer inner wall repair, we kind of sacrificed that one. We wanted to get the ribbish tube repair fixed first, and then we're going to go back to the combustor inner wall repair. So that's on track. We should have that done by year end. The PT nozzle flow honing, we've got that approved. We can now flow hone nozzles and adjust the EFA size. So those of you that have PT nozzles that are not performing or need to be larger, we can enlarge them, and you can work through Greer on that. The fielding the LTS high hop performance, we're still working on that. We're continuing to analyze it, and Jim's got some technical details he'll share with you in a bit. As far as Transport Canada approval of our LTS101 maintenance training, we first moved on the HTS 900. We wanted to get that done first. That's complete. It's actually approved by Transport Canada. Now we've got our LTS101 coursework in, and we're looking for that to be approved in October. The conversion engine on-time delivery, as many of you know, we were plagued with part shortages here, and we had quite a bit of trouble. We've got all that fixed. It's moving very well. We're delivering 4 engines a month, and we've actually got engines on the shelf ready for sale. The LTS101 nozzle availability, especially on the GP nozzle side, this is still ongoing. We're working with our suppliers. We're trying to get them to deliver the EFA sizes we need. That we're still struggling a bit here, but rest assured we're still working on it. The PT governor and the fuel control bearings, getting those fixed. I know this is a trouble spot for everyone, having to remove these items prematurely to have the bearings replaced. This is, unfortunately, it's ongoing. We've had a schedule slip, and now we've moved this into 2016, but every effort is being made, and we're watching this to make sure that it gets done. The last item was to package our HOC presentations and email to the customer base. We did this, recorded all of the presentations and sent them out. So hopefully you enjoyed those. Just in case you were wondering what we'll be working on for the remainder of 2015 and into 2016, we want to make sure that we're working on the cost drivers for direct operating cost. So number one on our list is the PT governor and fuel control bearing fix. That's getting all of our attention, and we're funding that completely, so there's no issues there. We're going to try to complete the combustor and the wall repair. That'll be hopefully available by the end of the year. And then in 2016, I've got funding in place to redesign and look at the entire design of the combustor liner. Many of you know that it's not lasting the full 1,800 hours in some cases. I think our reuse rate is about 60%, so it's driving some considerable operating costs. So we want to get that fixed. That'll start in January of 2016, and hopefully we can move through that pretty quickly. We've redesigned the HTS900 combustor liner. It actually runs hotter than the LTS101, so we're going to try to apply as much of that to this combustor liner and hopefully get some more life out of it. Performance improvement, again, we'll keep chasing the nozzles. We're working with the vendors. We're going to get that done. And then fielding the LTS101 high hot performance improvement, the MGT margin. That's ongoing. We're learning a lot, but we still don't have a package that we can deliver. What we have learned, we've implemented, so many of the engines are being produced with 35 plus degrees of margin. A new category is measurement, and we've kicked this off this year. We're going to start measuring some of the reliability, both the engine by model and of the accessories individually. In the past, we've always depended on the metrics for the 750 fleet, but now we want to look at the 700E2 and the 750 and the 850 fleet. We're going to start looking at the direct maintenance cost, which we think is about $120 per hour. We're going to look at what the key drivers of those are and have that in a Pareto chart so we're making sure we're working on the right stuff. Now, we know we are. With the 1, 2, and 3 we have at the top. Those are very significant. We'll get those done. But afterwards, the next item that I fund, I want to make sure it's a hard and a heavy hitter. And the next is customer satisfaction. And this year, some of you are going to join us at the Helicopter Association of Canada in Vancouver in November. And we're going to have our first users conference with a handful of Canadian operators. And we're going to talk about the engine and what it takes to make these operators more satisfied with the use. With that, I'm now going to turn this over to Jim Ebken. He'll go through the details of our engine projects. And please take it away, Jim.
Thank you, Doug. Hello, I'm Jim Ebken, Product Support Engineer for the LTS101 engine model. Welcome to the LTS101 technical briefing. Our aerospace technical support team is available through telephone, email, and through our myaerospace.com website. We have a cohesive team approach. Our ATS personnel, John Sanner, Jason Hall, Don McCombs, Bob Morey, and Roger Gibbs, are here to help. They receive calls, everything from lost data plates to different part conditions, operational conditions, and manual and service bulletin questions. We encourage customers to provide feedback to our cases for our continuous improvement. Our 2015 technical publication status. We've issued a couple of service bulletins, some updated CD-ROMs, 2 CSLs, one of the CSLs commercial service letters, one for our dry strut rear bearing support housing, and one for our technical publication subscription rates and Honeywell Aerospace Academy training opportunities. We have one service bulletin in work for the pneumatic PC filter housing, and we also have updates being planned for the LTS101 2.4 maintenance manual, 2.2 maintenance manual, and the Illustrated Parts Catalog 4.4. We're actively working changes to ensure up-to-date data is available to the technical community. Honeywell and CAE Training Solutions has 3 remaining LTS101 classes this year. One is in Shanghai in September, and we have 2 more classes here in Phoenix, one for line maintenance training and one for intermediate maintenance training. We encourage factory training to all technicians. Our 2015 850B2 engine update. We've shipped 80 conversion engines to date, and there are currently conversion engines available for immediate shipment. One of the best things about the 850B2 engine program is that we've initiated a 2,400-hour inspection extension program. Now, these engines must operate up to 2,450 hours to 2,550 hours to be a candidate, as well as during that period, there's no engine internal maintenance allowed. So we initiated this program in July of 2014. We have 5 engines enrolled. Our current high time operator has 2,360 hours since conversion. Okay, we'll get into a service bulletin update with the fuel pump. We issued Service Bulletin 264 in August of 2013, and we implemented a redesigned internal fuel pump drive spline. This was fielded to increase the time between inspection interval. This new pump also incorporates a cartridge seal that has eliminated fuel leakage. There's been no leaks reported since the introduction of this newer fuel pump. In August of 13, we extended the TBI interval from 600 to 1,200 hours. We're working the incremental TBI extension, and our next validation inspections are required at 1,200 hours for 10 pumps. Currently, we've inspected 5 out of the 10 pumps that have reached 1,200 hours. All the inspections have been successful. We have 1 pump that's pending inspection, and we have 5 pumps over 1,000 plus hours. 1,800 hours will be our next target. This upgrade is optional at next fuel pump access. We're on target to extend the fuel pump to 1,800 hours by second quarter 2016. We'd like to discuss our 700D2 power assurance margin program. The issue is some hot and high operators need a greater MGT margin to meet their operational requirements. Background: when we were required to install the dry strut rear bearing support housing to reduce carbon-related bearing damage, power assurance margins were affected by about 10 degrees centigrade. We implemented a major analysis program internally here in Phoenix, and we've run over 20 engine tests to date. We evaluated the GP turbine tip clearance to the turbine shroud. Our latest segmented cooled GP nozzle testing has provided us a 9-degree C improvement on performance. Currently, we are working drawing updates and a procurement plan to implement this segmented cooled GP nozzle, and we plan to have this fielded by the fourth quarter of 2016. We've also studied the GP and PT nozzles. We've optimized that, and we currently have the proper sized EFA nozzles available. Incorporating the proper sized nozzles within your engine will improve your MGT by 12 degrees centigrade. So continuing with the power assurance margin for the 700D2, we're reviewing the cylindrical solid ring shroud distortion. Right-hand side of the slide, you'll see a graph or illustration that shows distortion of that shroud that can be up to as great as 6 thousandths. That will greatly affect the turbine efficiency. So we're performing a match shroud grind study where we grind the GP shroud while installed in the rear bearing support housing. We're going to target a specific tip clearance, and we're going to validate this in engine test. We have several more planned engine tests. In addition to the improved tip clearance performance we're looking for, we also plan to allow grinding to reduce the requirement to replace a GP turbine if the tip diameter is slightly undersized. So in summary, Honeywell is improving the engine ship performance today by working closely with the service centers, replacing marginal performance parts, and we're moving forward with the segmented GP turbine shroud, and we're continuing analysis on the existing shroud. So this performance margin chart shows a cross-section of the engine with how we're optimizing 700D2 performance today at our service center network. Going from left to right on the chart, the compressor section, which would be the compressor rotor, the axial stator, diffuser. In some engines that we're enhancing the performance on today, the compressor may have slight erosion, may not be totally noticeable to the field technician. However, when we're trying to improve the performance margin, the compressor can give us up to a 13 degrees centigrade improvement by replacing a eroded compressor. Also, as we replace that compressor rotor with potentially a new one or one that's less worn, we also see an improvement of about a 1.3% fuel burn. The next area would be the seat clearance of the engine optimized from what it was as received, and in some cases we'll see up to a 10 degrees centigrade improvement. We've had one or two engines where the combustor curl fit to the gas generator nozzle was incorrect, and that gave us an 11 degrees centigrade margin improvement. As we optimize the GP nozzle EFA, in some cases we've seen up to a 8 degrees centigrade improvement. If we have worn GP nozzle seal rings, installing new seal rings will give us about a 1 degree centigrade improvement on MGT. With the GP turbine tip clearance, we've seen up to an 8 degrees centigrade improvement with a gas generator turbine rotor reblade, which optimizes the GP turbine tip clearance to the shroud, and the power turbine nozzle effective flow area improvement. When that's optimized, we'll see about a 4 degree C improvement. We had one operator recently that replaced a PT nozzle in the field with a larger PT nozzle EFA, and that operator was able to achieve a 15 degrees centigrade improvement with a field repair. These are actual observations from our service centers and our performance analysis. However, as we replace these components within the engine, they are not totally accumulative. So these are some of the items we've done within the past year to enhance the performance of the 700D2 engine model. So a little bit more on the performance margin study that we're performing here at Honeywell, and we're working with our supplemental type certificate holders, Soloy and Helilinks, is we've developed a kind of like a two-up chart. This chart on the left side in blue, this is a chart showing our uninstalled engine performance data as we look at it in the test cell when we're running the engine in the cell. And as you can see on the left side of the chart, uninstalled performance data, the green line on the chart designates our minimum engine ship limit. So that is our FAA requirement to ship an engine out at no higher than a certain MGT. As we endeavor to improve the performance margin of the engine, we target below the green line, which would be excess margin at engine shipment. So that would be our additional test cell margin goal. Now on the right side of the chart, kind of light red, this is our study for the engine installed in the helicopter. Now again, we want to start out at the green line on the chart, which identifies our minimum ship limit, our minimum engine shipment limit. So as you can see, from the engine minimum ship limit, when it's installed, we'll come up to the blue line, and the blue line identifies the installation effects. Once we take the engine out of the test cell, put it in the airframe, there's installation losses. Now, from our studies, we see that we lose probably about 30 to 35 degrees centigrade due to inlet and exhaust losses, plus there may be a little bit of additional loss there due to inlet barrier filter, whether it's clean or dirty. And it's a clean one may be 5 degrees centigrade, a dirty one could be up to 20 degrees centigrade installation loss. Now also with your installation effects or installation losses, we also sometimes find that the installation effects drive into aircraft instrument calibration issues. I know that the technicians are constantly checking the instruments for calibration and everything, but if you have an engine that's low power, this is some of the routine work that we do to try to improve that installed margin on wing. Okay, so let's go to the installed engine performance in the helicopter, and we'll go a little bit further to the right on the chart to where we show additional test performance with that engine. So you'll see we put another green line in the chart. So the more margin you have coming out of the test cell, the further it drops the installation effects line on the chart. So when we ship an engine that meets minimum spec, we believe that the operator will see about 10 to 20 degrees C power assurance check margin while the engine's installed. And then as we target below that min-ship performance, minimum engine shipment performance, then you'll see maybe 25 to 30 degrees margin or more. So this chart is really to show that Honeywell is not only studying what we're doing to improve the engine as it comes off the cell, we're also studying what happens when it goes on wing. And that is part of our installment to show you, the operators, that we're working as hard as we can to give you the highest performing engine possible. One last thing is we'd like to remind you, the technicians and the pilots, as you're doing the power assurance check, please try to perform the check as close to 95% torque as possible, and try to be as consistent with your performance checks as possible to give you the best possible trending of power assurance margins. Okay, we'd like to talk a little bit about the fuel control and power turbine governor bearing activities. So we've had some uncommanded power changes with the fuel control and power turbine governor bearings. If the bearing deteriorates in service, the engine power may decrease or increase. We'd like you to refer to our operational information letter, LT101-04, for additional operational symptoms. Okay, so our findings is initially the spool bearing, we saw some manufacturing contamination, and during that we noted that we needed increased design margin of the spool bearing. On the main drive shaft bearings, we have some external contamination that's suspected, and the bearing cage design margin could be improved. So we issued service bulletins to require both spool bearings and drive bearing to be replaced on both the fuel control and the power turbine governor. We've had some recent activity where we revised the single engine service bulletins to clarify when the main drive bearings are replaced. Those are our service bulletins A0268 and service bulletin 0272. Service bulletin compliance reduces the risk of bearing degradation. Fuel control and governor bearing redesign efforts. So our fielding goal for the fuel control with the later bearings is early second quarter 2016. Our FAA certification testing was initiated in July of this year. The new spool bearing for the fuel control has a 4x improvement in fatigue capability. We're using a later material, BG42, for the balls and raceways. We've reduced raceway curvature, and we've added an improved stainless steel separator. We're also using a new high temperature grease, RP6000 HT, in the spool bearing for temperature durability. The main drive bearings have an 8x improvement in fatigue capability using the same BG42 balls and raceways, reduced raceway curvature, and we're introducing a more robust meld-in separator. The grease type is going to remain the same as RT500 due to the requirement for blue grease, and the blue dye used in the grease will identify if a fuel washout of the bearing grease occurs. Power turbine governor redesign, we expect to field the newer bearings in the early fourth quarter of 2016. Our FAA certification testing is starting this month, September 2015. Another item to note is during our testing, we've identified that the power turbine governor operates about 50 degrees Fahrenheit above the fuel control. So the new spool bearing will have a 7x improvement on fatigue capability. We're using hybrid ceramic balls, silicon nitride, BG42 raceways with reduced raceway curvature, and the new RP6000HE grease for the temperature durability. This bearing is larger, and the larger envelope is going to require a larger cap and a change to the flyweights. The main drive bearing will have a 7x improvement in fatigue capability. We're using the BG42 balls, raceways, reduced raceway curvature, and the AMS 5514 stainless steel separator with the new higher temp grease. Okay, I'd like to shift gears over to the torque meter gear. Issue is we've had some locking nut feature cracking and bolt head breakage. Symptoms could be a chip light, low torque, noise during shutdown or during coast down. There's been no in-flight shutdowns reported. We find this primarily on external heavy lift usage machines. We've issued several service bulletin updates to our SB211. The latest one was issued in May of 2014, where we incorporated a new nut, had a thicker locking feature, and there's been no reports of that locking feature cracking. So our new action plan is we're going to incorporate a new bolt, so dash 12, 13, and 14 bolts. This is a high quality NAS bolt with rolled threads, or basically forged threads, and we're seeing a 15% increase in hardness, yield strength, and manufacturing control. This bolt has a larger head clamping surface to increase the bearing surface on the gears. You can see on the lower right pictures the clamping face of the bolt and the rolled threads. They're CAD plated, they're lighter golder color bolt. So the larger bolting head clamping surface is going to reduce clamping face fretting, and the CAD plating offers a consistent clamping force for a given bolt torque value. The new production gear assembly for the 700D2 engine and the 850B2s, 750B1s, 650B1s will be the 4081 350-24. That drawing is in work, and we're pending drawing release for the earlier gears going in the 600A3As and 600A3 and A2s. So we're also going to offer a field gear assembly rework, and that's going to be through our service bulletin 211, and that's going to only be allowed at service centers. The reason for that is during the incorporation of these new bolts, the gears need to have some reworks on the bolt hole to put a chamfer on them to accept the newer bolts. Our plan is to order the new gears and issue the rework service bulletin by the fourth quarter of 2015. Okay, the next update is going to be on our oil coking with the number 2 and 3 bearing oil feed jets. The issue is we had number 3 bearing distress quite some time ago, back in 2008. This is still on our radar, and we had carbon formation within the oil feed strut that clogged the oil jets. We've had 5 successful oil-related service bulletins. Our closure plan is to complete field data collection, analyze it, and show that all the modified engines are showing great operational success, and we request your help to get your Delta P data trend over 1,800 hours so we can close this service-related defect program we have. As we close, the data that we receive may allow future Delta P check extension to the 150-hour interval. We've had some difficulty with the flow fence actuator adjustment. This primarily happens on the 750B1 engine and 850B2 engine, and we've been seeing about 2 to 4 units per year that have not been able to be adjusted properly while the engine's installed. We found some binding between the bellows anti-rotation pin and the cover where it bottoms out against the cover's anti-rotation slot. We've also recently seen some service center difficulty in adjusting the unit to the test specification. We're evaluating the bellows spring rate on 6 units and the static height of that bellows that could also attribute to this problem. So the status is we're continuing to evaluate these return bellows. We have reviewed the flow fence actuator engineering model versus the engine test cell adjustment requirements and the engine field adjustment requirements. Typically in the field with these engine models, you fine-tune the flow fence actuator full open point to ensure that the aircraft does not have unacceptable torque splits between the engines. So evaluation of the existing cover rework design has been initiated, and we're reviewing alternate adjustment procedures at the repair station to alleviate this issue. As I mentioned earlier, the PC filter housing service bulletin, we had a power reduction last year with a PC filter part number 4301-17601. What our findings were is we had indications of high strain fatigue between the PC filter inlet fitting and the PC filter body. So one piece assembly. The likely cause is stress from an unsupported T-fitting during the B-nut torquing process. So as you can see on the photographs on the right-hand side of the page, the furthest top right-hand picture shows where the PC filter is located on the engine, and then there's a close-up picture showing the PC filter fitting was cracked and leaking. Now, our action is we're developing a service bulletin. It's to inspect all part number PC pneumatic filters. We're going to need to perform a leak check, inspect the filter for cracking, and we're going to call out the proper torque technique, which is to restrain the T during torque application. As you can see on the bottom right photograph, you'll see the bottom T fitting, which is being restrained with a wrench on the left-hand side of the bottom photo. The right-hand side of the photo is showing the correct torque being applied to that B-nut with a torque wrench, or the B-nut or cap with a torque wrench. We have a new PC filter being designed, which has a thicker walled fitting. We also like you to refer to our engine maintenance manual and commercial service letter 109 for proper tube and fitting assembly. The service bulletin is planned for release this October. We've had some successful repair developments this year, and the first one is our service bulletin 103 for the dry rear bearing support housing. The first item is we've had 100% success cleaning carbon from the tubes with our later PyroClean process. The next success is completion of the repair to the P3 buffer air and oil scavenge tubes. This was just completed July 2015. Since approval, we've shipped 7 units and we're ramping up capability, resolving some detailed part availability issues. Next item is the effusion combustor liner repairs. We completed the outer wall repair 2014, and we've since shipped 15 repaired units to the field. Most recent success is completion of the inner wall repair just August, and we're ready for units to be returned for inner wall repair. The dome has not been noted as a primary rejection component, and with such a low rejection rate, it is not deemed economically repairable. We've completed the PT nozzle effective flow area adjustment by abrasive honing, and we've shipped 30 units to date. Contact your approved LT101 repair facility for all of your repair work. That concludes our technical briefing. Thank you.
Thank you. I really want to thank everyone for joining us today. I hope you find this information useful to your business. We want to keep you informed as to what we're doing and let you know that we are, in fact, working all of these issues. The corporation has been very generous to us in funding our projects, and we're going to keep moving. We're going to take care of all the problems that we have. I look forward to seeing some of you in Vancouver in November, and I hope to see all of you at our Operators Conference in Louisville in March. So thank you again. Appreciate you joining, and goodbye, everyone.